let's start. Our next speaker is Gaetan Zoritchak, and he will talk about Kotlin Multiplatform. Gaetan, it's all for you. Let's start.
Okay. Thanks for coming here. So I will talk about Kotlin Multiplatform, and I will give a feedback about our experience of developing a Kotlin Multiplatform library. So the first half of the talk will be more general on Kotlin Multiplatform, and then we'll go back more on our experience. So my name is Gaetan Zoritchak. I live in France, and I usually work in Switzerland because I just live near the border. And I'm going to start with some Kotlin facts and a little bit to remind a little bit what is Kotlin, the history of Kotlin, and where we are now. So Kotlin starts, the work on Kotlin starts in 2010, and it has been really publicly announced 1 year later. And they wait 5 more years before the first release of Kotlin. At that moment, Kotlin was only for the JVM, and for JavaScript it was working, but it was still experimental. 1 year later, with Kotlin 1.1, it was usable for the JVM and for JS. There was this Google announcement of Kotlin support for Android development during the Google I/O last year. And at the end of the year, with Kotlin 1.2, we had this Kotlin JVM and Kotlin JavaScript that was usable as a multi-platform code, multi-platform project. And with the last version of Kotlin, so it was 1 month and a half ago, we now have Kotlin native, which is still in a beta version, but there is another multi-platform way of doing project, and now we can use also Kotlin native in Kotlin JS, in Kotlin multi-platform project. So since Kotlin has been launched, a lot of people have been using it. And I will just give you some numbers about, first, the love the language have. This is a survey from Stack Overflow, and this year they ask developers, what are the language that you love? And Kotlin appears to be the second loved language. So a strong place because quite far ahead some other language like Python, TypeScript, Go, and so on. It's also the fastest growing language on GitHub. The contributor on GitHub, the growth is quite huge. And this is confirmed by the numbers from JetBrains that shows that actually there is more than 1.5 million of Kotlin developers. And it was the numbers of October, so it should be quite bigger now. And this is the last graph I will show you. This is really interesting, is how developers use Kotlin. And we see that the vast majority of developers use Kotlin for the mobile development. But if you see, if you sum the numbers, you see that it will be much more than 100%. So that means that a lot of developers are using Kotlin on different platforms. So maybe they are using Kotlin for mobile and server, or for server and JS. So this is really interesting because it means that we have here a lot of people that could be interested by Kotlin multi-platform development. If you use it already on 2 platforms, maybe you are going to be interested by the fact of sharing some code between 2 platforms. So now let's talk about Kotlin multi-platform and what it is. So basically, it's this. It's some code that you can compile on different platforms. So at first, you had Kotlin for the JVM, so you just have your Kotlin code, and it was compiled into bytecode. You have the same for Kotlin.js. So Kotlin.js is transpiled into JavaScript file. And now you can have some kind of module which is named common, and the code that is in this module is going to be one time compiled into Java bytecode, and one time is going to be compiled into JavaScript, transpiled into JavaScript. So depending on how your common code is used, for what project, for what platform, the resulting compilation is different. And you have the possibility in the code to say, okay, this is some common code, and in that code I have a function for which I don't know yet the implementation. So I add this expect keyword, and this expect keyword just says to the compiler the implementation is going to be given by the targeting module. So here my common code can use this expected function, but the implementation is given here, for example, in the JVM, and here as JS using console log. And so expect keyword is a kind of saying, okay, this code is going to be provided at runtime. And this works also for class. So you can expect to have a class. You don't have the implementation now. So you put the expect keyword onto a class, and then you give the implementation in the target platform. Don't hesitate to ask questions if you have during the talk. So what are the use cases for Kotlin multiplatform? So there is this first use case, which is quite simple, which is only to share maybe some code between a server and a client, some kind of DTO, a little bit of business logic. But you won't share a lot of code with that use case. Oops, sorry. Another one is to say, okay, maybe I have two clients. I have a JavaScript client and a mobile application, and I can reuse a part of my logic, of my client logic application in a common module. So it could be to manage the communication with the server, the authentication, to manage some state, and depending on how your client application is designed, you can reuse quite a lot of code. So this is another use case, which is isomorphic web application. So the idea is that a web application can be rendered by the server or by client code. And we have a common library in Kotlin, which is called Kotlinx HTML, which can generate some HTML, and it's working on the browser or on the server. So you can reuse the same code to say, okay, this is a component, and the code, the HTML com and the DOM manipulation, one time will be done on the server, and the other time will be done inside the client application. So now we have Kotlin native. So Kotlin native is now in version 0.9, so it will be quite soon. It should be delivered in version 1.0. So that means that we can also use Kotlin to implement, to develop some iOS application. So you can use all the iOS APIs, and that means that now you can share your code between an Android application and an iOS application. So that is more code to share. And I would like to show you another example, which is this code is from, I don't know if some of you know the database Xodus. No? Nobody? It's the database that is behind uTrack. UTruck is a bug system of JetBrains. And it's a database that is embedded, it's a Java database that is embedded in the server. So you just have to declare the dependency of, on Xodus, and you can use the database. And Xodus is written partly in Java and partly in Kotlin. But what is more interesting is they have this library which defines the model of the database. So here I'm declaring an entity which name is user, and it has a username which is required with a minimal length, and it has an email, and I've got some constraint property on this property, and I can also define some links between my entities. So imagine that this code, which is a definition of your domain objects, if this code could be common. So now you could be able to share the definition of the model on each part of your application. And today, when we say, okay, this property is an email, we have to do some specific code on the JS part, on Android part, on iOS part. We have to do some verification on the client. We have to do some verification on the server. And if you know that the type is of a certain type, you can reuse this code and this knowledge on every layer of your application. So that means that you could reuse a lot of code. And even you could use this model definition to say, okay, I want to retrieve a part of the graph from the server. I just want to save a part of it. And this could be a really interesting way of using Kotlin multi-platform. So if you find the time to create this library, it could be good for Kotlin. Okay, now I'm going to talk about our experience of using Kotlin multi-platform. So I've been working on this project, which is named DataViz. So it's an open source library. And we started to work on it 1.5 years ago. And this is what you can do with it. So here is what we call a core diagram. This is an animation using line of sight, certain kind of algorithm. We have 4 Cs algorithms that are useful to perform some kind of animation. We also have geographic projection, so you can take a GeoJSON objects and just render them in a visualization. And this is working exactly the same on Android, JavaFX, and inside the browser. So it's the same code that is run on every platform. So how did we did that? So we take D3GS, which is a known library in JavaScript to do data visualization, and it has a lot of algorithms, and we port them into Kotlin. But Kotlin, D3GS is working that way. I mean, it's it's doing some kind of manipulation on the DOM, so a kind of low-level manipulation, and you have to know exactly how, what is the grammar or SVG to modify the DOM to do a certain type of rendering. We didn't do that. Instead, we decided to create some abstraction of the visual elements. So when you do the data visualization, you are just using few basic elements, which are circle, rectangles, lines, path, and stuff like that. And so we have this kind of object in the common part of the library. And the developer is interacting with this object. And then we are using different type of rendering system that just push the memory version of the object onto canvas. So it's quite easy to do it. And the difference between D3GS and our version is that the state is stored in memory. It's not the DOM that holds the states. So this is the object we have at least one layer, and after we have all these kind of basic elements. And next, we'll plan to create an iOS renderer and maybe a WebGL renderer, we'll see. And this is the difference of code. So this code is the same. This is Distro.js, this is Kotlin with our library. So here you see that it's really basic manipulation. So you say select all G, because you have to know that G is a group. Here you append a circle, and a circle, you say, okay, the attribute of circle is R. R is for radius, but if you don't know that it's R, it's not going to do anything. On the other end, here you have the Kotlin version of it. So when we say circle and we open a block, inside that block we are inside a circle object. So the IDE is able to help us and to say, okay, if I'm starting to write R and I just press Control space, I will have the radius because the IDE knows that I'm inside a circle. We also, here you see, that is also kind of very strange. I mean, you say this attribute is going to be a transformation, and you give as a string the definition of the translation. What we can do in Kotlin is to have some small internal DSL. So when I'm starting this block, I'm inside a transformation. So the compiler knows what I can do inside a transformation. So I can do a translation, I can do a rotation, stuff like that. And also we have some nice Kotlin features like property extensions that allow to, for example, to create an extension property on an integer and to create a color from an integer. And so we did that, and so we port nearly all the modules from D3.js, and we still have some work to do, but we have nearly maybe 80% of the features of D3.js that are now available on DataViz. So what is the work you have to do when you are doing multi-platform development? So basically the work is aligning platform APIs. Because you are developing something in a common way, and you want to have all the behavior that is the same on each platform. And for that, you don't have the same APIs. So for example, for us, we are doing rendering. So we start with the coordinate system. So hopefully the coordinate system is the same on each platform. So the X and Y axis are on the same direction. But then you have to work with the angles. And here it starts to be more difficult. Because in JS, you have radians, and the direction is positive in the clockwise direction. When you take JavaFX, it's degrees, and the direction is the opposite. And when you take Android, it's even something else. So it's not very difficult for the moment, but it starts to be a little bit complicated. And after you have the API, so when you want to draw, for example, an arc on each platform, in JS, you will have that. So you give the start angle, the end angle, and the direction of your draw. On JavaFX, you give the start angle, but you give the sweep angle. And on Android, you give the bounding rectangle, the start angle, and the sweep angle. So your job as a multi-platform developer is to do managing all those differences and to do the right call to have the same result. And sometimes, for example, you don't have there is nothing in the API, so you have to do the job. On Android, there is no arc2 function. There is one, but it's not the same as in JS or JavaFX. So you have to do the trigonometry and to draw what you want for arc2. So another part of the job is testing, and to be sure that everything is working the same on each platform. So for common code, there is no problem. We didn't find any difference on each platform, and you can have some testing code, and this testing code is going to be run on every platform, and we never found any problems. But after you have to test your specific platform code. And this is the moment where it starts to be a little more tricky. And for us, because we wanted to be sure that the rendering was the same on each platform, so what we did, we created some visualization and do the rendering on each system and then compare the images. So I don't have a lot of time, but the idea is that on JS we use Puppeteer to do the rendering and create the snapshot image. On Gradle, on JavaFX, it's quite easy because we have a function on Canvas. And on Android, it's a little bit more complicated because you do the testing inside a simulator, so you have to pull back the image from the simulator. And this is the result, for example. So here I have a small test visualization, and I do the rendering, and I can see that I have a difference on the second image. And I have a library that do the pixel comparison and say, okay, you have 10,000 pixels that are not the same on this image. Okay. So currently we have what is interesting is that we have more than 95% of our code that is common code. That means that we could port the essential of the code into Kotlin multi-platform code. So this is just, so for the moment we have Android, JavaFX, and JavaScript. And these are the next features that are coming. And we also plan to do some plugins to help people developers using the library. And we are also creating, on the top of the open source library, we are creating a charting library. So the idea is that you have a nice DSL to create some charting, and you just have to do the modification in that code. And that code could be seen as configuration code, but it's real code. And that is what is nice with Kotlin is your DSL are quite likely like configuration code. So you just have to modify your code, and you see how it, what is the resulting visualization. We have some two applications to test and to show you how the result of the application, and we are currently working on some thing. I'm going to show you that. I'm going to share my So, and we are creating this this platform, and the idea is to help people play with. It's going to work. Yes. So it's an online platform where you can try the code of the library and see immediately the result of it. And so you have some Kotlin code here on the left, and we compile and give the result immediately in live. So it's so this is some work with the force, for example. And here, if I just remove some up. Now you can see how it's working. So it's a tool that will help you understand the mechanism, the algorithm, all what is available in the library. So it's currently in beta version, but you can see the normal version, I can say. Going to on play, and here you will have all the tutorials about the library, and you can just change the code, execute it, and see how it's working. So it's live. It's a nice way to play with Kotlin code. So I think that I was so fast because I thought it was too short. So in fact, I have a lot of time for the question now. So.
Thank you for your demo. I have a couple of questions for you. First of all, how are you dealing the cases when this library has major updates, like from versions 3 to 4 or 5?
Sorry?
How are you dealing with the cases when this JS library has major releases, like changing versions?
There is, it's completely new code. I mean, we just took the existing code, but we just rewrite everything. So it was more an inspiration. So this JS is about 20,000 lines of JavaScript code, and we have, I think now it's 14,000 lines of code. So we still have a lot of geographic projections that we didn't make, but it's more the principles are here, and so after, I mean, this JS can make his own version, and we are completely inspired from it.
Okay, so the second question is about iOS. Why are you not currently supporting it? Is there any tough challenges?
So for the moment, I think it's not made sure enough. I mean, the compilation is quite slow, and maybe in just 2 or 3 months it will be better. But for the moment, the development experience is not so good. So I prefer to wait a little bit and not spend too much time, dealing with all those small problems. There are not a lot of examples, so we have a lot of work to do. So we must share our time correctly. Other questions?
Ребят, если у вас есть вопросы, можете задать их на русском, мы переведем.
Thank you. Since you're planning to work with 3 more platforms with Kotlin, have you encountered any boundaries or limitations while working with new generated classes written in Kotlin?
No, not really. I mean, the work of JetBrains team is really good there. I mean, they are not creating how can I say? They are not creating a framework. I mean, you have access to all what is available on each platform. So when you are inside iOS, you are dealing with the iOS APIs. When you are in Android, you can do whatever is possible in Android. When you are in GS, you can do all that you want. So for the moment, I don't see limitation on it. The only problem is what is available as a common code. So you need to have enough to do that. So for the moment, we have some, for example, date is a problem because everything has to deal with date. And we don't have any date common way of doing it. So for your project, you will have to deal with this limitation and say, okay, I have those 2 platforms, so I know how I want to use dates, and so I will manage it in my code and not in using an existing library. But the library are coming. So for example, it's the same for the communication. There is now an HTTP client library that is working on all platforms, so you don't have to manage it in different way on each platform, and you just can reuse this common library. Is that answering your question? Okay.
Thank you for your lecture. Did you hear about Filament SDK and
Filament?
Filament.
Yes, but it's the Google.
Yes, there is some similarity with your library. I missed the first part. Then I have this question.
I think the similarity is that Romain Guy is French and is working on it, but it's a C++ library, so it's really, and it's more on 3D. So our purpose is really on data visualization, and I think that 2D is better for data visualization. In most cases, it's easier to communicate with 2D visualization than 3D. And Filament, I think, is more to do some 3D rendering, and not for visualization, but maybe more for games or stuff like that. So,
thank you.
Hi, thank you for the talk. And the question is, I'm checking currently your GitHub account of the library, and I wonder if there is a way to integrate the library into like existing, let's say, client-side project that is not written in Kotlin. How the library is delivered, as like what kind of artifacts you support. I mean, there is specify that we can use Maven artifacts, but as far as I can see.
So for the moment, it's available on Maven Central. So all the artifacts are on Maven Central, so you can use it easily in the Kotlin project, just adding the dependency on
the Kotlin project.
On Kotlin project.
And if I have just JavaScript-based app, like
for the moment, we didn't work a lot on that. I mean, if you want to, the interest of using Kotlin is also what Kotlin can provide for writing DSLs and defining your visualization using a Kotlin language for the DSL. So then you can say, okay, I want to use it on another without Kotlin, but partly you will have to do it on Kotlin. And our choice was more to say, okay, Kotlin is a successful language, and it's going to have a lot more project and people using Kotlin. So we are not working on saying, okay, you can use it, but use it in another technology. It's not the point for the moment. I think we have enough people using Kotlin for Android, and to keep that that space, and not to go on, not to say we are going to do everything.
Okay, I see. Thank you. And am I right that basically it's possible to use the same artifacts for Android app written in Kotlin?
Yeah.
And for Kotlin app that targets client side.
If your project is a multi-platform project, you can have a dependency on different artifacts. But if you are just using JS, Kotlin JS, or just Android, so you just pick the dependency on the Android version of the library, and it will work. And your code, you can define your visualization as in common code, and the same code is going to be executed inside a JavaScript application, or inside Android app, or inside JavaFX.
That's all questions for now. If you want to ask any additional questions, you can find Gaetan near. Okay, thank you, Gaetan.